So for optimization, let's go back to this type of problem. So on the quiz, we did distance to the curve. Um, this is another type of distance problem that we looked at. And if you recall, the prerequisite skill for this section was that when given a right triangle, now we all know a squared plus b squared equals c squared, but recognizing that c can be written as the square root of the legs squared. Okay, so you can pause the video if you need to and read this. And well, you probably would need to. We need to know what the problem says, but we're trying to decide where to put that wire so that we minimize the amount of wire needed. So we're trying to connect this top to this top, and we have to stake the wire somewhere in the middle. So we're going to have the distance of this hypotenuse and the distance of this hypotenuse, and we want to minimize the total distance. Okay, so first question is, do we call this y? Right, some students label this y. The problem would be when you go into your calculator, you can't enter something with both x and y in it. So we say, okay, well then, what would this distance be in terms of x? Okay, and I hope you recognize that it would be 20 minus x. Okay, so pause the video and try to write a formula for D1 and then D2. Okay. So if you're back, you would have done D1 is x squared plus 6 squared, 36. Then the quantity, so make sure it gets put in parentheses, 20 minus x for D2 squared, plus you might not know 15 squared off the top of your head, but your calculator does, so go ahead and just enter 15 squared into your calculator. Okay, so you're going to grab your calculator and you're going to do this plus this. Okay, the most important thing with using your calculator on optimization problems is setting your window correctly. Okay, but we know, what are the possible x values? Well, x could be anything from 0. If it were 0, it would mean bring the line straight down and connect right there. So 0, between 0, there should be an equal sign under there, but I don't have that on my keyboard. The greatest value of x could be 20. Okay, so set your window 0 to 20, and then after you type in your equation, then you do zoom fit. Okay, so you type in this plus this in the same line. Okay, then you do a zoom fit, and after you graph it, it should look like this. Okay, so notice I did this plus this. Okay, when you have the radical, this whole quantity that's under the radical has to be in parentheses, but then you end the parentheses, space over, and do the next one separately. You should get a graph that looks like this. So you do the second calculate, and you do the second calculate min, right? And then you do the whole left bound, choose min, left bound, right bound, right? So you X off somewhere over here, somewhere over here. It'll ask you to guess. You don't want to guess, and then it'll finally give you this. So then the answer to the problem, this is the distance, and rounding to 1 decimal point is good. This is the distance from that 6 foot pole, 5.7, and then this would actually be your total distance. So I only asked in this problem, how far over from the pole should you stake the wire, but if I had asked what's the minimum total distance, that would be the y value. And that's it.